Alright, welcome. This is part 2 of the Module 6 review sheet for the test. This one is going to cover part 5, 6, 7, and 8. Okay, you're going to use the definition of a reflection to answer the following questions. The image of a point of A, 3, comma, negative 5 after reflection is the point A prime. The line of reflection intersects A prime at the point negative 1, comma, negative 2. What must be the coordinate of A prime? The question is really worded weirdly, but so I decided to draw the information for it to make sense. This is what it means. There is a point here at negative 1, comma, negative 2. Okay? Alright, and there's a line of reflection that goes through it. Okay? Then there needs to be a line of reflection that intersects A and A prime. That's what it means here. Okay, so the distance here from A to the line of reflection, okay, is this hypotenuse. I think it's 5. Okay, because it goes up 3 across 4. If you do the Pythagorean theorem here for this right triangle, you should get 5 here as the hypotenuse. That is the distance from A to the blue, right, which is the line of reflection. So that distance of 5 would be the same thing here, right? So again, I just did a 180 degree rotation, okay? Or I basically reflected across that axis, along this line. So I reflected, goes up there, 4, 4, 3, 3. Okay, the point here is A prime, right? That is what it's looking for. Okay, what is the coordinate of A prime? It's that. This part just means this. Okay? Part 6. For the following, what is the angle of rotation that will carry it onto itself? Okay? So, there's a formula. 360 divided by S, or the number of sides. Okay? N, I use N here, right? So, N here is 3, because an equilateral triangle has 3 sides. I should have used S equals to 3. Same thing, 360 divided by 3 is 120. So if I rotate this 120 degrees, it would still be the same shape, or look like it would be the same shape. Next, a square. A square has 4 sides. 360 divided by 4 is 90. A regular pentagon has 5 sides. 360 divided by 5 gets you 72. Hexagon has 6 sides. 360 divided by 6 gives you 60. Sorry. And a rectangular heptagon has 7 sides. 360 divided by 7 is around 51.4. Right? I didn't use the equal sign here. I had a round. That's why I used the approximate. Right? It's 51.4 degrees. Okay? That was part 6. Again, you just have to memorize that formula. 360 divided by N, or S. Part 7. Okay, the coordinate plane shows the location of 2 figures. Enter the missing information which describe the transformation of triangle LKM to triangle L prime, L prime, K prime, and M prime. Triangle LKM is rotated what point? Triangle LKM is rotated around what is the center of rotation? It's right here. Okay, I'm gonna grab this, pull it up in paint. Alright, give me a second so we can work in paint so you can see it much better. Alright, it's gonna make more sense. Okay, hold on. Alright, here you go. Grab my original. Watch this. Okay, it's right here. That was my original. Rotate. Right, hold on. Right, watch this. Oh, sorry. Watch this. It was right here. Right click, rotate 90 degrees. That's what this object was. Then, right, rotate 90 degrees. It was this object. Then rotate it again 90 degrees. Boom, this object. You see? That was after 290s, so it's basically a 180 degree transformation. Okay, there you go. Notice I show the perpendicular line, right? I show that triangle, the right triangle rotating. So this was the original. up 1 across 2, perpendicular, right? That was your first 90, then perpendicular again, right? There you go. That was your 180. So we would say that it rotates around what point? The center here is 0, 0, right? This was 90, become here, 90 again, right? 290s becomes 180. This object had a 180-degree rotation, clockwise or counterclockwise, okay? It's symmetrical, right? And we would say it has a 180-degree rotation, and the rotation is around the point 0, 0. You could also call that the origin. Number 8, looking at this object, right? It's not symmetrical, so be very careful. Okay, does it have a rotation of 90 degrees above the origin? Right? No, it doesn't. It has a 100-degree. It has a 270-degree rotation above the origin. Okay, counterclockwise. So clockwise would look. Does it go counterclockwise? Counterclockwise would go this way. Right. So let me show you here in Paint. I'll show you what I mean. Okay. Right. Look. Right. I grab this object. Okay, and I'm gonna rotate it like what it says here, 90 degrees counter, right? Boom, it would look something like this right here, right? Doesn't make sense, okay? So it wouldn't be this one. It wouldn't be the first one. Would it be a 270 degrees clockwise rotation, right? Counterclockwise rotation? Let's see that, right? It's gonna look weird. Hold on, give me a second, right? This would be the first 90. Then we do another 90. Then we do another 90. Oh, hold on. Sorry. Left 90, that would be your first one because we're going counterclockwise. Then we do another left 90, right? Then we do another left 90, right? So yes, it would be this one, right? That would be, say yes, it would also be a counterclockwise rotation of 270. Would not be a 180 because 180 should be right here. Would it be a clockwise rotation of 270? No, because it would end up right here. Okay, counterclockwise of rotation of 45, not even close. But counterclockwise rotation of 270 is the same thing as a clockwise of 90 degrees above the origin. I would just want to make sure you understand that this and this are the same thing. Counterclockwise of 270 is the same thing as clockwise of 90. Same thing here. Counterclockwise of 90 is the same thing as clockwise of 270. Okay? 180 and 180 are the same. Clockwise or counterclockwise, if it's symmetrical. Part 9. Using this image, used to answer each one of the questions. How many endpoints does the ray have? You see the dot? That's an endpoint. So we would say it has one endpoint. Should not be two. It should be one. This is one endpoint. This goes on forever. So it should be one, not two endpoints. One endpoint. Sorry about this. One. Hold on. Right? It should be one. Okay, one endpoint. How many degrees does it how can you tell that two lines are perpendicular? It intersects here and creates a 90-degree angle at the intersection right there. Okay, how can you construct two angles using rays? Right, this is a ray. So what you can do is you could have two rays and they start at the same vertex. The starting point here is a vertex, that's a vertex, that's a vertex. Okay, that's how you make lines using vertices. Okay, and let's go to the next one. Give me the definition of circle. Again, it's a point inside the circle, odd distance on the circle, or equidistant, same distance from that center point. That distance is defined by the radius r. Describe the similarities and differences between parallel lines. Talk about the slope and the wide-intercept. So parallel lines have the same value slope, but different y-intercepts. Right? So that is just 9. Okay, we went over 5, 6, 7, 8, and 9. I decided to go 5 problems on this one. Okay, there you go.